Welcome to Don't Die Dumb, the channel that helps you expand your knowledge and better understand the world around you. Today, we're diving into one of the most fascinating topics, the human brain. This 3-pound organ inside your skull is the command center of your entire being. It dictates everything from how you think and feel to how you move and interact with the world. Did you know that the brain makes up about 2% of your body weight, but consumes 20% of your total energy? Let's explore some of the most unusual facts about this amazing organ. You know that feeling when you stub your toe and it seems like your entire nervous system is on fire? Well, here's a mind-blowing fact. Your brain doesn't feel a thing. That's right, the brain itself has no pain receptors. The pain you feel from a headache actually comes from the tissues surrounding your brain, like your scalp, blood vessels, and meninges. This absence of pain receptors in the brain allows for some pretty incredible things. For example, neurosurgeons can perform awake brain surgery. Patients can be awake and even interact with the surgical team while doctors operate on their brains. This helps surgeons avoid damaging critical areas that control things like speech, movement, and sensation. So the next time you have a headache, remember that your brain isn't actually hurting, and spare a thought for the wonders of neurosurgery, made possible by the brain's remarkable ability to feel no pain. Our senses, sight, smell, taste, touch, hearing, we usually experience them as separate channels of information, but imagine a world where those channels get crossed, where the taste of chocolate evokes the color orange, or the sound of a violin conjures up the scent of cinnamon. Sounds wild, right? Well, that's the reality for people with synesthesia, a rare neurological condition where the stimulation of one sense triggers an automatic, involuntary experience in another. Imagine seeing colors when you hear music. That's called chromesthesia, and it's one of the most common forms of synesthesia. People with chromesthesia might see vibrant bursts of red and orange when they hear a trumpet blast, or calming shades of blue and green during a piano melody. But synesthesia isn't limited to just sound and sight. Some people experience tastes when they read words, a phenomenon known as lexical gustatory synesthesia. For them, the word Tuesday might taste like strawberries, while the word computer evokes the tang of grapefruit. We don't fully understand what causes synesthesia, but scientists believe it's due to increased cross-wiring between different sensory areas in the brain. Famous synesthetes include the artist Wassily Kandinsky and the musician Pharrell Williams. Synesthesia reminds us that our perception of the world is subjective and that the brain is capable of creating extraordinary sensory experiences. We rely on our vision so much that it's hard to imagine navigating the world without it. But what if I told you that some people who are blind can still see in a way? This phenomenon, known as blind sight, reveals the astonishing complexity of the visual system. Blind sight typically occurs in people who've suffered damage to their primary visual cortex, the part of the brain responsible for processing visual information. While these individuals are not consciously aware of what they're seeing, they can still respond to visual stimuli in their environment. Imagine someone with blind sight walking down a hallway. They might be able to navigate around obstacles even though they claim to see nothing. It's as if their brain is processing visual information on a subconscious level, allowing them to react to their surroundings without actually seeing them. Blind sight is a powerful example of just how much our brains are doing behind the scenes without our conscious awareness. It highlights the intricate interplay between different brain regions and challenges our understanding of what it truly means to see. We've all had those moments where we feel like our brains are overflowing with information, but just how much information can this incredible organ actually hold? Well, get ready to have your mind blown. Scientists estimate that the human brain has a storage capacity of up to 2.5 petabytes. 1 petabyte is equivalent to 1 million gigabytes. To give you a sense of scale, just 1 gigabyte can hold roughly 300 hours of high-quality MP3 songs. Now multiply that by 1 million, and you're starting to get a sense of the brain's mind-boggling storage capacity. In more tangible terms, 2.5 petabytes is roughly equivalent to 3 million hours of TV shows. So how does the brain manage to store such a vast amount of information? The answer lies in its intricate network of neurons and synapses. Your brain is home to approximately 86 billion neurons, each capable of forming thousands of connections with other neurons. These connections, called synapses, are the junctions where information is transmitted between neurons. Each synapse can transmit about 1,000 signals per second, contributing to the brain's overall computational power. This vast storage capacity allows us to learn languages, remember faces, master skills, and accumulate a lifetime's worth of experiences. For centuries, scientists believed that the adult brain was a fixed and unchanging entity. Once you reached a certain age, the prevailing thought was that your brain's structure was set in stone, and any significant damage was irreversible. Fortunately, we now know that this is far from the truth. The human brain possesses an extraordinary ability called neuroplasticity, which is essentially its ability to reorganize itself by forming new neural connections throughout life. This remarkable ability allows us to adapt to new experiences, learn new skills, and even recover from brain injuries. Imagine the brain as a bustling city with intricate road systems. Neuroplasticity is like the city's ability to reroute traffic, build new roads, and create detours in response to changing conditions. When we learn something new, whether it's a new language, a musical instrument, or even a new way of thinking, our brains are literally rewiring themselves to accommodate this new information. One of the most powerful examples of neuroplasticity can be seen in stroke recovery. Thanks to neuroplasticity, the brain can often reroute functions around the damaged areas. Other parts of the brain can step in and take over some of the lost functions, allowing for varying degrees of recovery. This ongoing rewiring of the brain is essential for cognitive flexibility, creativity, and our ability to adapt to a constantly changing world. Have you ever noticed how a particular smell can instantly transport you back in time, evoking vivid memories and emotions? It's like a sensory time machine, whisking you away to a specific moment from your past. This powerful connection between smell and memory is no coincidence. The olfactory bulb processes smells and connects directly to the amygdala and hippocampus. These regions play key roles in emotional responses and memory formation. Think about some of your own most powerful memories. Chances are, many of them are associated with specific smells. So, the next time you encounter a familiar scent, take a moment to appreciate its power to unlock memories and emotions. For a long time, the prevailing belief in neuroscience was that we were born with a finite number of brain cells, and that was it. Once these precious cells were gone, they were gone for good. However, groundbreaking research in the late 20th century shattered this dogma, revealing that the adult brain is capable of generating new neurons, a process known as neurogenesis. This discovery revolutionized our understanding of the brain's potential for growth and repair. While neurogenesis is not as widespread in the adult brain as it is during development, it does occur in specific regions, particularly in the hippocampus. Think of the hippocampus as the brain's library, where new memories are formed, catalogued, and stored for later retrieval. Neurogenesis in the hippocampus is essential for maintaining this cognitive flexibility and our ability to form new memories throughout life. One of the most well-established ways to boost neurogenesis is through exercise. Aerobic exercise in particular has been shown to increase the production of brain-derived neurotrophic factor, BDNF, a protein that acts like a fertilizer for brain cells, promoting their growth and survival. Mental stimulation is another key player in neurogenesis. Challenging your brain with new and complex tasks such as learning a new language, playing a musical instrument, or engaging in puzzles and brain games can help to stimulate the birth of new neurons in the hippocampus. So, the next time you're feeling mentally sluggish, remember that your brain has the remarkable ability to generate new cells. That's it for today. I hope you gained some fascinating insights into the human brain, that 3-pound universe we all carry around inside our skulls. We explored its ability to withstand pain, its capacity to blend senses, its potential for blindsight, its vast storage, its remarkable adaptability, the profound link between smell and memory, and its capacity for regeneration. From feeling no pain to regenerating cells, the human brain is truly an awe-inspiring organ. If you enjoyed this journey into the wonders of the mind, give us a thumbs up and subscribe to Don't Die Dumb to catch all our exciting episodes. Feel free to leave us a comment with more topic suggestions. Until next time, remember, stay smart and stay curious.